Hello everyone. Last class we have discussed about Venn diagrams and union, intersection and difference of two sets, union of two sets and intersection of two sets, and with the Venn diagrams. Okay. So in that we have to write for what is A union B. How we should write in set builder form: A union B, A intersection B, A minus B, and B minus A. Okay. So first I am writing A union B. A union B. A union B is equal to what? X such that X belongs to A or X belongs to B. Okay, this is the set builder form of A union B. A union B is equal to what? X such that X belongs to A or X belongs to B. Next, A intersection B. A intersection B, X such that X belongs to A and X belongs to B. And X belongs to B. So it means we have to write the common elements of A and B. Okay. Next, A minus B. A minus B. The difference of two sets A and B. So here X such that X belongs to A and X does not belongs to B. X does not belongs to B. Why? Because when we are doing subtraction, we have to write the remaining elements in A set only, not B sets. So that those elements belongs to A, not in B. Those elements are A elements only, not B elements. Okay. Next, B minus A. X such that X not belongs to A and X belongs to B. Not belongs to A and X belongs to B. Okay, these four are first one A union B and A intersection B and A minus B and B minus A. The first one is X such that X belongs to A or X belongs to B. The second one A intersection B is equal to X such that X belongs to A and X belongs to B. Next, A minus B is equal to X such that X belongs to A and X does not belongs to B. Fourth one B minus A, X such that X does not belongs to A and X belongs to B. Okay, last class we have discussed about disjoint sets. Okay, so shall we discuss one problem based on disjoint sets here? For example, the difference between two disjoint sets is what? Okay, the intersection of two disjoint sets. What is the intersection of two disjoint sets? For disjoint sets any intersection part is there? No. Why? Because there is no common element of both the sets. There is no common element of both the sets. Those sets are, we can call it as disjoint sets. Okay, so here I am asking one question. What is the intersection of disjoint sets? What is the intersection of disjoint sets? That is a null set. Okay, how we can justify? Why? Because there is no common element of set A and set B. Then only we can call it as disjoint sets. Okay, so finally the intersection of disjoint set is null set. Okay, null set, that is represented by the phi symbol. That is phi symbol. Okay, now we are going to do some problems. Okay, if A is equal to 6, 9, 11. If A is equal to 6, 9, 11, then find A union phi. Find A union phi. Okay, phi means what? Null set or empty set or void set. Okay, so A union phi is equal to A union phi equal to, first write the elements of A. 6, 9, 11 union phi means empty sets. Phi means empty set. So already we know empty set is subset of all the sets. Empty set is subset of all the sets. So A union phi is equal to, union means what? We should combine the elements of two sets. So here in null set any element is not there. Then finally what is A union phi? A union phi is equal to 6, 9, 11. 6, 9, 11. Same elements in the A set. Why? Because that is a null set. In null set there is no elements. So A union 5 is equal to 6, 9, 11. So A union 5 equal to 6, 9, 11 is A. Yes or no? So A union 5 is equal to what? 5. Next, if we do once, you can write A intersection 5. A intersection 5. So A is equal to 6, 9, 11 intersection 5 means null set. Okay. Now, what is the A intersection B? Intersection means we can take the common elements of both. We can take the common elements of both. Here any common elements are there? There is no common elements of set A and 5. So there is no common elements means what? Represented by null set. So A intersection 5 is equal to null set, that is equal to 5. So just you remember it. A union 5 is equal to A and A intersection 5 equal to 5. A intersection 5 equal to 5 and A union 5 equal to A. Okay. Next, if A is equal to 4, 5, 6, if A is equal to 4, 5, 6, B is equal to 7, 8, find A union B and B union A. Okay, concentrate here. A union B and B union A. First we have to find out A union B. Okay, what are the elements of A? 4, 5, 6. Union B elements 7, 8. B elements are 7, 8. Union means what? Combine the elements of two sets. So A union B equal to 4, 5, 6, 7, 8. Combine the elements of two sets 4, 5, 6, 7, 8. Okay. Next, coming to B union A. B union A is equal to B 7, 8 union 4, 5, 6. 4, 5, 6. Here also A union B also combine the elements of A set and B set. B union A also combine the elements of B set and A set. So B union A is equal to what? 4, 5, 6, 7, 8. We should combine the elements of two sets. We should write the elements of set A and set B. While we are writing, should not repeat the elements. Okay, that is, remember it. Now here A union B also 4, 5, 6, 7, 8 and B union A also 4, 5, 6, 7, 8. So finally we conclude that A union B equal to B union A. A union B equal to B union A. Okay. Next, A is equal to 2, 3, 5. A is equal to 2, 3, 5. Find out A union 5 and 5 union A. A union 5 and 5 union A. Okay, so here 5 represents empty sets, void set or null set. Okay, see. So A union 5 is equal to A union 5 equal to A 2, 3, 5 union 5 means empty sets. 5 means empty sets. So union means what? Combine the elements of two sets. So we should combine same elements, we can get 2, 3, 5. 2, 3, 5. So here 2, 3, 5 is equal to what? A. So finally A union 5 equal to A. A union 5 equal to A. The next one is 5 union A. Once you find out 5 union A. 5 union A set. The elements of A set is 2, 3, 5. The elements of A set is 2, 3, 5. What are the union of the empty set and 2, 3, 5? So we should combine the elements of two sets. Here empty set. In empty set there is no elements. So union section is 2, 3, 5. Here also 2, 3, 5. So 5 union A is equal to what? 5 union A, 2, 3, 5 elements means A only. So finally we conclude that A union 5 also A, 5 union A also A. So we can give the comment A union 5 equal to 5 union A equal to A. Equal to A. All the answers are A only. A union phi also 2, 3, 5 we got. So that is the set A elements. Next phi union A also 2, 3, 5, that is A elements. So finally we are writing here A union phi equal to phi union A equal to A. Okay. Next, based on this union and intersection, what is the value of if A intersection B, sorry, if A subset B, if A is subset B, what is the value of A union B, and what is the value of A intersection B? What is the value of A union B and what is the value of A intersection B? This is one mark question. Sometimes they will ask in part B. If A is subset B, then what is the value of A union B? What is the value of A union B and what is the value of A intersection B? Compulsory question. See, A subset B. Already we know subset. What is meant by subset? Here all the elements of A set present in B set. Okay, now all the elements of A set is present in B set. Okay, so A union B is equal to what? For example, here 1, 2 is there. A, the elements of A are 1, 2. The elements of B is 1, 2, 3, 4, 5. So those 1, 2 elements are present in the B set. Okay, so finally if we are doing union, what will happen? We will get the set B. Union means what? Combine the elements of B set. Combine the elements of two sets A and B. So here A subset B. When A is subset to B, then A union B is equal to B. A union B is equal to B. Why? Because here the elements of set A is present in the B set and extra terms also there in B set. So when we are doing union, we should combine all the elements of the set A. Or after combining, we will get B set only. We will get the B set only. Why? Because this all the elements of A is present in B, already there in B. Okay, I will give one example. Here A is equal to AEIOU. A is equal to AEIOU, set of vowels in English alphabet. Next, B is equal to set of all the letters in English alphabet. All the English alphabet means A, B, C, so on up to Z. See here, once you observe, A is equal to what? Set of vowels in English alphabet. B is equal to total English alphabets. Okay, total English alphabets. So now A subset B is correct or B subset A is correct? Here A subset B is correct. A subset B. Why? Because all the elements of A, E, I, O, U, these 5 elements are present in B set. In B set, these 5 elements are available. Okay. So finally, if A is subset to B, finally we will get A set or B set. If A is subset to B, if when we are doing A union B, we will get B or A. B is a big set compared to this. In these two sets, B is the big set now. So combining all the elements of A set and B set, finally we got B. Okay, so A union B is equal to what here? A union B is equal to B. And when we are doing A intersection B, intersection means common elements. Which are the common elements of A set and B set? AEIOU are common. Okay, in this set also AEIOU there. In this set here already given AEIOU. Okay, so AEIOU are the common elements of both sets. So A intersection B is equal to A. A union B is equal to B and A intersection B is equal to A. This is a very important. Very important. Okay, I am writing one question. If A is equal to X such that X is a set of natural numbers. Set of natural numbers. Next, B is equal to X such that X is a even natural number. is a set of even natural number. Next, C is equal to X such that X is a set of odd natural numbers. Add natural numbers. Okay. Next, D is X such that X is a set of prime numbers. Set of prime numbers. Find out A intersection B, A intersection C, A intersection D, B intersection C, B intersection D, and C intersection D. So here given question, indirect question this is. These all are here given in set builder forms. We are converted into roster form and we have to do the problem. Okay. Now A is equal to X such that X is a set of natural numbers. Here B is set of even natural numbers and C is set of odd natural numbers and D is set of prime numbers. See here, A is equal to what? Set of natural numbers. Start from 1, 2, 3, 4, 5, so on. 1, 2, 3, 4, 5, so on. Next B is equal to set of even natural numbers. 2, 4, 6, 8, so on. Okay. 2, 4, 6, 8, so on. Next C is equal to set of odd natural numbers. Those are 1, 3, 5, 7, so on. Next D is X such that X is a set of prime numbers. Set of prime numbers are 2, 3, 5, 7, so on. 2, 3, 5, 7, so on. So finally we are writing roster forms. The set builder form converted into roster form. Now A intersection B. A intersection B. So which are the common elements of A and B? Here the A set is 1, 2, 3, 4, 5. Intersection. The B set is 2, 4, 6, 8, so on. 2, 4, 6, 8, so on. Now what is A intersection B? Intersection means the common elements of both the sets. This here all natural numbers. Here even numbers. So the remaining are odd numbers. Yes or no? So finally here what are the common elements here? What are the common elements? Here 1, 2, 3, 4, 5. Here even numbers. Even numbers are common for both. Yes or no? So 2, 4, 6, 8, so on. These are set of even numbers. Represented by B only, no. So that is equal to B. Next, A intersection C. A value same 1, 2, 3, 4, 5, so on. Intersection the C, set of odd natural numbers. 1, 3, 5, 7, so on. Odd natural numbers. So in these two sets, which are the common elements? Here are total natural numbers. Here odd natural numbers. So the odd natural number is common for both. So 1, 3, 5, 7, so on. This odd natural number set is represented by C. Okay. So A intersection B is equal to B and A intersection C is equal to C. Next A intersection D. Here also same. A total natural numbers start from 1, 2, 3, 4, 5, so on. Intersection. Here D represents what? Prime numbers. Set of prime numbers means 2, 3, 5, 7, 11, so on. Okay. So in this all the natural numbers, prime numbers are available. Okay. So here D is subset of A. Here also C is subset of A. Here B is subset of A. Okay. So here if D is subset of A, now A intersection D is equal to what? D. Just now we have discussed. Okay, so what are the common elements here? Prime numbers are common elements of natural numbers and the prime numbers. So that is equal to 2, 3, 5, 7, so on. The prime numbers are in D set. The elements of prime numbers is in D set. So that is equal to D. Next, B intersection C. B intersection C. See B intersection C. B means what here? Set of even natural numbers. Set of even natural numbers. 2, 4, 6, 8, so on. These all are even numbers. Even natural numbers. Intersection C. C is set of odd numbers. Set of odd numbers. 1, 3, 5, 7, so on. So now what is the intersection part of both? Once you observe it, here B is set of even numbers, here C is set of odd numbers. Set of even, set of odd. There is no common element of both the sets. Here completely even sets, here completely odd. So here there is no common elements. So if there is no common element, we should represent with a null set. So this is a null set. Okay, so that is equal to 5. So B intersection C is equal to 5. The next one is B intersection D. B intersection D, 2, 4, 6, 8, so on. Intersection D is set of prime numbers. Set of prime numbers 2, 3, 5, 7, 11, so on. Now once you check it, what are the intersection part of here? Set of even and set of prime. Only we have one even prime. What are that even prime? That is 2. So the answer is 2. The answer is 2. This is even prime. Next, finally C intersection D. C intersection D. C is set of odd numbers. That is 1, 3, 5, 7, 9, so on. Intersection D. X is set of prime numbers. Set of prime numbers are 2, 3, 5, 7, so on. 2, 3, 5, 7, so on. So in that, what are the common elements of odd natural numbers and prime numbers? What are the common elements of odd natural numbers and prime numbers? Except to all the prime numbers. Except to all the prime numbers are common of odd natural numbers. So that is equal to 3, 5, 7, so on. Except 2. 2 is not a odd natural number. 2 is not a odd natural number. 2 is not present in odd natural number set. So we can't write 2. If we can't write 2, the remaining prime numbers are the common elements of odd natural numbers and the prime numbers. Understand? Okay. The next topic is equal sets. Equal sets. I am giving one example. Okay. So here we are observing there A is equal to Sachin, the elements Sachin, Dravid, Kohli. These three are elements in the set. Sachin, Dravid, Kohli. These three elements. We can see B is equal to Dravid, Sachin, Dhoni. Dravid, Sachin, Dhoni. C is equal to Kohli, Dravid and Sachin. Okay, how we should identify which are equal sets, which are not equal set? So here A and C. Once you observe A and C, all the elements are set A and all the elements of set C are equal. Okay, but positions are different. Here Sachin is first position, here Kohli. Next Dravid, here Kohli, Sachin. Here three elements are same. If the elements of two sets are same, those two sets we can call it as equal sets. So here based on these examples, here A and C are equal sets and B is not equal set. Why? Because here Sachin, Dravid, Kohli is there. Here Dravid, Sachin, Dhoni will be. Dravid, Sachin, Dhoni. That's why A and C are equal sets and B is not a equal set. So here A is equal to B sets, and A does not belongs to B, and B does not equal to C. Here A is equal to B, A does not equal to B, and B does not equal to C. Okay, so when A set and B set are equal, we should write A is subset to B and B is subset to A. Both are subset to each other. Why? Because all the elements of subset to all the elements of A in set B, all the elements of set B is present in set A. So if A subset B and B subset A, then A is equal to B. A is equal to B. Okay. One more example. A is equal to X such that X is a letter in word. Letter in the word wolf. WOLF. Next, B is equal to X such that X is a letter in the word. Letter in word follow. Okay. Next, C is equal to X such that X is a letter in word, that is flow. Wolf, follow, flow. Now according to the set builder forms, we have to write the roster form. We have to write the elements of set A, W, O, L, F, B, F, O, L, W, C, F, L, O, W. Once you check it, the elements of A is W, O, L, F, B is F, O, L, W, C is F, L, O, W. All the elements of same of set A and set B and set C. So these three are equal sets. So A is equal to B is equal to C. This set A and set B and set C are equal sets. Why? Because here all the elements of set A and set B and set C are equal. So that's why we can call it as equal sets. Next, finite set and infinite set. Finite set and infinite set. Finite set and infinite set. What is mean by finite set and what is mean by infinite set? Okay, so finite set means what? Finite set means some reach point is there. Infinite set means infinitely we can't reach the point. So finite set and infinite set, which elements are countable? Those types of sets we can call it as finite sets. Those types of set we can call it as finite set, and which are uncountable. Those which are uncountable elements in the set, those type of sets we can call it as infinite sets. Okay, now let us try with example. See here, for example, all months in a year, X such that X is a month in a year. That is what finite set. Why? Because we know in year 12 months are there: January, February, March, April, May, June, July, August, September, October, November, December. Only 12, should not be add any month. But we are not uncountable here. Okay, we can count all the months. Okay, so what? X such that X is a month in a year, that is a finite set. For example, set of natural numbers. There is not given any limits. That type of sets we can call it as infinite sets. Why? Because where it should be end we don't know. Okay, for example, set of natural numbers from 1 to 10 or 20 to 30 or less than 100 means finite set. Okay, if they won't give any limits, if will not give any limits means that is a infinite set. That is the difference between finite and infinite. Finite and infinite. Here see set of points in a line, for example. Set of points in a line. When I am drawing one line here, how many points are there? We are not uncountable. That is not possible to count all the points on the line. So see here what x such that x is a set of points on the plane, means a infinite set. Example, finite set means what? Finite set x such that x is a set of months in a year, or else set of set of fingers in our hand. Okay, like that, they all are finite set. Okay, if they are given limits, set of prime numbers, set of natural numbers, set of whole numbers, these all are under infinite set. Finite set means limits, set of prime numbers from 1 to 10, set of natural numbers below 100, set of whole numbers from 20 to 30. Okay, like that given means that is finite set. Okay, next one, the last topic is cardinal number of set. Cardinal number of sets. Okay, so here a is equal to, for example, a is equal to 1 2 3 4 and b is equal to 3 4 5. B is equal to 3 4 5. Just now we have discussed about A intersection B, A union B and A minus B. For example, A union B. A union B is what? The combined elements of two sets, 1 2 3 4 5. 1 2 3 4 5. Okay, next A intersection B is equal to what? Intersection means common elements of both the sets, that is 3 comma 4. Next A minus B, what? A minus B is equal to cancel the same elements and we should write the remaining element set A in set A. So here 3 4 get cancelled. The remaining elements of set A is 1 2. Next B minus A. B minus A, what? Here we should write the B elements first. Set B elements right first, next A elements. So here we should cancel the 3 and 4. The remaining elements of set B is 5. So B minus A is equal to 5. So already we know A union B, A intersection B, A minus B and B minus A. Already we have discussed it. Now cardinal number of sets means here A union B. Cardinal number means we have to count the elements in the sets. That is represented by number of A. Number of A means how many elements are there in the set A. Here how many elements are there in the set A? 1 2 3 4. So number of A is equal to 4. Next, number of B is equal to how many elements are there in the set B? 1 2 3. Okay, so number of B is equal to 3. Next, number of A union B. Number of A union B means in A union B how many number of elements in there? How many number of elements are there? 1 2 3 4 5. So number of A union B is equal to 5. Next, number of A intersection B is equal to 2 and number of A minus B is equal to 2 and number of B minus A is equal to 1. Number of B minus A equal to 1. Here number of A 4 elements are there. In B set 3 elements are there. In A union B set 5 elements are there. In A intersection B 2 elements are there. In A minus B 2 elements and B minus A 1 element. So finally we conclude that based on this we have one formula, that is number of A union B equal to number of A plus number of B minus number of A intersection B. Minus number of A intersection B. Once we have to verify based on this problem. Number of A union B. Number of A union B is equal to what? 5. phi equal to number of A. Number of A is equal to 4 plus number of B is equal to 3 minus number of A intersection B is equal to 2. So phi equal to 4 plus 3 7 minus 2. So phi equal to 5. Phi equal to 5. Like that we have verified. So number of A union B is equal to what? Number of A plus number of B minus number of A intersection B. When we have to use this formula, for example, we know number of A, number of B and number of A intersection B. Number of A intersection B. How we should find number of A union B? Directly we have to use this formula. Number of A plus number of B minus number of A union B. According to this formula, what is number of A intersection B? If number of A intersection B comes to this side, this positive becomes plus. So number of A intersection B equal to number of A plus number of B minus number of A union B minus number of A union B. Number of A union B. So number of A intersection B. If you want to find out A number of A intersection B, number of A plus number of B minus number of A union B, and if you want to find out number of A union B, number of A plus number of B minus number of A intersection B, we can call it as here number of or n of. That is our wish. N of A plus n of B minus n of A intersection B. Okay, here we know these two formulas. For example, A and B are disjoint sets. Okay, A and B are disjoint sets. What is n? A number of A union B. Okay, for the disjoint sets there is no intersection part, so we have to eliminate this part. Okay, we have to eliminate this part. Only for disjoint sets, number of A union B is equal to what? Number of A plus number of B. Okay, why? Because here number of A intersection B is equal to 0. Number of A intersection B is equal to 0. Why? Because here for disjoint sets the intersecting part is null set. In the null set there is no elements, so number of A intersection B is equal to 0. When we are doing for null set, for disjoint sets, we are using this formula. Number of A union B is equal to number of A plus number of B. Why? Because number of A intersection B is equal to null set. There is no elements in the null set, so number of A intersection B is equal to 0. Okay, thank you.